Welcome, developers and architects. I am your expert technical instructor. Today, we are diving deep into the responsible use of AI, focusing specifically on understanding the risks and limitations of generative AI tools like GitHub Copilot. Let's build secure, trustworthy workflows together. Welcome to this deep dive on the risks and limitations of generative AI tools, specifically within the context of GitHub Copilot and responsible AI principles. While AI presents incredible opportunities for innovation and efficiency, it introduces significant risks that developers and organizations must carefully manage. One of the primary concerns is that AI systems can make decisions that are difficult to interpret. This opaque decision-making process leads to a distinct lack of transparency and accountability. Generative AI tools are also prone to unintended and potentially harmful outcomes. These can manifest as biased decision-making, where the AI favors certain patterns over others, or severe privacy violations if sensitive data is inadvertently exposed. To counter these systemic issues, we must establish robust governance frameworks, ensure absolute transparency in our AI processes, and maintain strict human oversight. Responsible AI is all about developing and deploying these intelligent systems in a safe, trustworthy, and ethical manner. It requires keeping human goals at the center of the design and respecting enduring values like fairness and reliability. Throughout this module, we will explore the specific limitations of GitHub Copilot, from hallucinated APIs to context window constraints, and discuss exactly how you can mitigate these risks in your daily development workflows. When building AI-assisted workflows, it is crucial to recognize that Copilot is not an autopilot. Developers must understand that the AI is a product of its training data and underlying algorithms. It is not capable of conversational interactions beyond its coding scope, and it cannot replace human programming. By acknowledging these fundamental limitations, we can set up secure environments, like the Copilot setup steps YAML file shown here, that pre-install dependencies and ensure the AI operates within a controlled, predictable sandbox, minimizing the risk of erratic behavior. This flowchart maps out the primary risk categories of generative AI. At the top, we identify opaque decisions and unintended harms, which split into bias and privacy violations. Critically, all of these threat vectors converge on a single solution. They must be mitigated by robust governance and unwavering human oversight. Moving deeper into the technical risks, one of the most critical limitations of GitHub Copilot and Copilot Chat is the generation of inaccurate code. Copilot may produce code that appears perfectly valid at first glance, but is actually semantically or syntactically incorrect. It might completely misinterpret the developer's intent or generate code that fails under specific edge cases. A unique risk of AI tools is the phenomenon of hallucinations, where the AI invents APIs, libraries, or functions that do not actually exist. Furthermore, Copilot might ignore explicit constraints you've set, use incorrect logic, or suggest deleting failing tests rather than actually fixing the underlying code issue. Be highly skeptical of code that looks right but doesn't perfectly match your architectural intent. To mitigate the risk of inaccurate code, you must carefully review and test every generated suggestion, especially when dealing with critical or sensitive applications. You must ensure that the AI-generated code strictly adheres to your team's best practices, established design patterns, and the overall architecture of your codebase. Never treat Copilot's output as infallible. It requires the same, if not more, rigorous scrutiny as code written by a human colleague. Copilot Chat is specifically designed to address coding queries exclusively. If you ask it non-coding questions, it may generate completely irrelevant or nonsensical answers, further highlighting the need to use the tool strictly within its intended domain. Always maintain a zero-trust approach to AI outputs in production environments. Consider this JavaScript example, where we ask Copilot to fetch user data. An AI might hallucinate an endpoint or a method on the database object that doesn't exist in our actual schema. As a developer, you cannot blindly trust the suggested fetchActive method. You must verify that this method is accurately defined in your specific data access layer. Additionally, when using Copilot Chat, remember that it is explicitly not designed to answer non-coding questions. If asked about unrelated topics, it may generate irrelevant or nonsensical answers. This diagram illustrates the necessary evaluation flow for AI suggestions. Just because an AI suggestion passes the syntax check doesn't mean it passes the logic check. If logic fails, it's a hallucination or bug. Even if both pass, the code must absolutely flow through human code review before reaching production. Another profound limitation of generative AI tools stems from their heavy reliance on their training data. GitHub Copilot's suggestions inherently reflect the patterns, coding styles, and potential flaws present in the billions of lines of code it was trained on. Because these sources may include the biases and errors of the original human contributors, Copilot can inadvertently perpetuate these biases and outdated practices. For example, if a certain vulnerable pattern was common in older open-source repositories, the AI might suggest it as a valid solution today. Furthermore, Copilot's performance is not uniform across all programming languages or frameworks. It might perform significantly differently depending on the scripting language or coding style being used. While it excels in widely used languages like Python or JavaScript, it may produce suboptimal, incomplete, or highly biased suggestions in niche or older languages. There is also the ongoing industry debate regarding the copyright implications of code generated from models trained on public repositories. As a responsible developer, you must be aware that the AI does not inherently understand fairness or modern compliance. It merely predicts text based on historical data. You are entirely responsible for ensuring the final code is unbiased, up-to-date, and legally compliant. This is why testing models with balanced demographic samples and reviewing training data is a key principle of responsible AI at Microsoft. When you evaluate Copilot's output, consider whether it's relying on deprecated APIs simply because they were prevalent in its training set 10 years ago. It is your job to bridge the gap between the AI's probabilistic text generation and your organization's rigorous, modern engineering standards. To combat language bias and outdated practices, you should utilize custom instructions. By defining a Copilot instructions markdown file in your repository, you explicitly tell the AI which modern frameworks and standards to use. For example, you can force it to use PNPM instead of NPM, or explicitly forbid the use of deprecated legacy libraries. This overrides the model's tendency to rely on the broader, potentially outdated patterns found in its global training data, forcing it to align with your specific, modern repository conventions. Here we see how custom instructions mitigate training data bias. Security and privacy risks are paramount when discussing generative AI limitations. Copilot generates code based on the context of your active files and prompts, which can potentially expose sensitive information or introduce severe vulnerabilities if not managed carefully. The AI might suggest code that is syntactically correct but fundamentally insecure, such as generating SQL queries vulnerable to injection attacks, or front-end code susceptible to cross-site scripting, or XSS. To combat this, Copilot utilizes a proxy server in Azure that runs prompts and completions through toxicity filtering, actively blocking hate speech, and filtering out personal data like names or identification numbers to protect user privacy. However, the system is not foolproof. Another significant risk is the generation of code that matches existing public repositories. To mitigate this, administrators can enable a matching public code filter. This crucial safeguard prevents Copilot from returning suggestions over roughly 150 characters if they closely resemble existing public code on GitHub, protecting your organization from accidental copyright infringement and intellectual property disputes. Furthermore, while Copilot temporarily processes data for safety filtering, you must be extremely cautious when using Copilot CLI or custom agents. If you grant an AI agent shell execution permissions, a prompt injection attack could trick the AI into executing destructive commands. Always verify generated terminal commands before execution, and strictly control tool permissions to prevent unauthorized access. When requesting AI assistance for sensitive tasks like authentication or database queries, you must apply rigorous secure coding practices. The provided SQL snippet shows how a naive AI suggestion might concatenate user input directly into a query, causing a severe SQL injection vulnerability. You must actively refactor AI-generated code to use parameterized queries or prepared statements. Always verify that you are not committing secrets, hard-coded passwords, or API keys that the AI might have hallucinated or pulled from your local environment variables during context gathering. This visual traces the secure prompt lifecycle. The user prompt goes to the Azure proxy server, hitting a toxicity and PII filter. If it passes, the LLM generates the code. Finally, the matching public code filter checks for copyright risks. Another critical limitation of generative AI is its context window and its inability to grasp highly specialized domain knowledge. GitHub Copilot Chat currently operates with a context window limit, such as 4,000 tokens for standard models. This means it can only see a limited amount of your codebase at any given time. If you ask it to refactor a massive architecture spanning dozens of files, it will lose context and generate fragmented or hallucinated solutions. You must be mindful of these limits by breaking down complex problems into smaller, focused queries. Additionally, Copilot excels at code-level tasks, but often fails to grasp complex, high-level architectural decisions, or highly nuanced business logic. If your custom business logic is poorly documented or lacks clear patterns, Copilot agent mode will struggle, leading to inaccurate solutions and an increased need for manual intervention. The I cannot inherently understand the why behind your company's unique domain rules. It relies entirely on the explicit context you provide through well-documented code, README files, and targeted prompt instructions. Furthermore, I cannot replace human creativity in solving truly novel problems. It is a powerful pattern-matching engine, but when faced with unprecedented technical challenges, it will attempt to forcefully apply known patterns that may not fit. You must use the 4S method of prompt engineering. making your prompts single, specific, short, and surrounded with context to guide the model effectively. When the context window is exceeded, Copilot will silently drop older information, which can lead to incredibly subtle bugs if you are relying on a long, continuous chat session. To mitigate context window limitations and domain knowledge gaps, you must master the art of curating context. Instead of relying on the AI to guess your architecture, explicitly attach relevant files, use Copilot spaces to anchor the chat in a specific set of documents, or provide a detailed prompt file like the API security review markdown shown here. By feeding the AI highly specific, curated context, you maximize the utility of its limited token window and bridge the gap between its general training and your project's unique business logic. This diagram highlights the danger of the context window limit. If a complex project request exceeds the token limit, context is dropped, leading to hallucinations. To safely leverage GitHub Copilot despite these inherent risks and limitations, organizations must adopt a defense in-depth strategy centered on human oversight. You must automate what you can by integrating robust CI/CD pipelines, employing static analysis tools like CodeQL to catch security flaws, and using Dependabot to track vulnerable dependencies introduced by the AI. However, human standards still matter immensely. Implement collaborative code reviews where teammates scrutinize AI-generated changes for readability, maintainability, and architectural alignment. Remember the core accountability principle of responsible AI. People, not machines, are ultimately accountable for the systems they deploy. GitHub Copilot is your AI pair programmer, an assistant meant to augment your skills, not a replacement for human judgment and domain expertise. By understanding its limitations, from hallucinated APIs to context window boundaries, you can harness its power safely and effectively. Thank you for joining this deep dive into generative AI risks. To master more advanced AI workflows and elevate your engineering career, visit quicktechie.com for comprehensive certification guides and expert-led training. The ultimate mitigation strategy is comprehensive automated testing combined with human review. When Copilot generates a new feature, you must also prompt it to generate rigorous unit and integration tests, explicitly asking it to cover edge cases and negative input scenarios. In this example workflow, we enforce a strict policy where AI-generated code is automatically scanned by CodeQL in our actions pipeline. Only when the code passes static analysis, automated tests, and a mandatory human peer review is it allowed to merge into the production branch. Furthermore, always encourage your team to verify the sources and licenses of any new packages or libraries the AI suggests, guarding against slop squatting or incompatible licenses. By actively managing these risks, you transform Copilot from a potential liability into a massive productivity multiplier. Ready to become a certified expert? Head over to quicktechie.com right now and enroll in our full GH-300 mastery course. Our final flowchart maps the ultimate defense in-depth mitigation strategy. AI code generation must flow through unit testing and CodeQL static analysis. Crucially, it hits the human peer review gate.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. We have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.